Sorry, close the iPad again. Anyways, what I was going to say is Z is 68, but they're not asking for Z. They're asking for measure of angle U. So there's actually quite a bit left in this problem. Okay, so, but now that we know Z is 68, we can plug that into these expressions to figure out what angles V and angle T are. So let's just do angle V. That'll be enough. So measure of angle V is equal to Z plus 44. We found that that is 68 plus 44. Here we're going to get a 2, and we're going to get 112 degrees. So these 112 degrees, what is U? Well, it's a parallelogram, so this one plus this V plus U has to be 180. So if we want to figure out angle U, we can do 180 minus 112, which is 68. What? Should I have known that some weird way? Angle U, measure of angle U is equal to 180 minus Z plus 44. So 180 minus, 180 minus 44 is, what the heck is happening here? 180 minus, well, let's not spend time trying to figure out how it happened to be the same as Z. Let's just go ahead and plug it into the answer. Watch, it's wrong. 68, I said, right? I hope. Submit. Awesome. Okay. It happened to be the same. Not really sure why that happened, but I don't really want to spend time trying to figure it out. Okay. So this is also a good one. We should do this one. Okay. So this is another property of parallelograms that we haven't discussed yet, and that is that the diagonals bisect each other. So the length of this half is the same as this half, and the length of this half is the same as this half. Now, you might be wondering, are all 4 of those halves the same length? And no, they don't have to be. Not for a parallelogram. Now, when you get more specific and you ask about a rectangle or a square or a rhombus, that's a different story. But for parallelograms, they don't have to be the same. And is there like a drawing I could give you so you can see that pretty clearly? Yes. This right here is a parallelogram. This side is parallel to this one. This side is parallel to this one. And when you draw the diagonals, notice how short this one is, but how long this one is. So all 4 of them don't have to be the same length, but each individual half piece has to be the same. So those 2 are congruent to each other, and then these 2 are congruent to each other. Okay, so yeah, what we have is that these 2 diagonals they bisect each other. Okay, so they're saying Tx is Z minus 19. So this right here is Z minus 19, and Vx is 3Z minus 89. 3Z minus 89. So what's the relationship between those two parts? They're actually equal to each other. So we can write that z minus 19 has to be equal to 3z minus 89. We have z's on both sides. I'm going to move this one over, cancels out, minus z. We're left with negative 19 on the left, and 3z minus z is 2z minus 89. Add the 89, add 89. That gives us 70 is equal to 2z. Divide by 2, divide by 2. Z equals 35. So Tx is, my bad. Z is 35. They're not asking for Z. They're asking for Tx. Tx, they told us, is Z minus 19. It's literally what it says at the top. Tx is Z minus 19. So we have to plug in our Z in there. Okay, so we got Tx equals 35 minus 19, which is 16. So this is equal to 16. 16, done. Let's plug it in. Check it, 16. Okay. All right, I think we're good there. Those two angles would be congruent to each other. So you would set those expressions equal to each other. Okay. N7. Proving a quadrilateral is a parallelogram. Okay, so for this you need to know some of the things that parallelograms have. Some of the properties parallelograms have. So we're given this quadrilateral, and they give us a few of the angles in there. They say 108, 108, and 72. I thought this would be way easier. I have to take a picture of this one. So let's not turn the iPad off again. Okay, so we got 108, 108, 72. This would be a parallelogram if this was what? If it was the same as this one. So if this was 72. Now, is there a way to check that it's 72? I guess we haven't actually done the following. I mean, I gave you the fact, but we haven't actually done this. How many total degrees should there be inside the quadrilateral, like between all four of the interior angles? It should be a total of 360. Now, since there's only one left, we should be able to figure out what it is, because we can do 360 minus this 108 minus the other 108 and minus the other 72, and that'll tell us what's left over for the last angle. Okay, so oh my gosh, 108 and 108 is 216, and then plus 72 is 882. So we're actually doing 360 minus a grand total of 288, which is going to be, if this was 80, it would just be 80. That's going to be 8 less, so it's 72. So this is 72 degrees. So this is 72 degrees, and that's the same as the opposite side. And this is one of the properties of a parallelogram, that the opposite sides are congruent to each other. And that does imply that it is a parallelogram. Some of you might be saying, Delamo, we know that parallelograms have opposites angles congruent, but can we conclude it backwards, that if we know the opposite angles are congruent, then that implies it's a parallelogram? And the answer is yes, you can do that. And if you remember, that's called the converse. So, like when we did converse of alternate interior angles and things like that. Yeah, in this case, the converse is true. So yeah, the fact that this is 72, that does imply that this is a parallelogram, because opposite angles are congruent. So this is submit. Yes. Okay, can you show this quadrilateral as a parallelogram? This one's a no. The reason it's no is because we don't have enough information. So we can't assume that this is 112 down here, because they're asking us if it's a parallelogram. Can you show that this is a parallelogram? So we're not allowed to assume that it is, in which case we would be able to make the conclusion that it's 112 and that this is 69, but we can't do that. And we also cannot use the fact that all four angles add to 360. We can't do that because we would have, the equation would be 69 plus 112 plus something for the bottom angle. So let's erase this since it's not true. Something for the bottom angle and something for the angle on the right. Should be 360, but this is two unknowns in one equation, so we can't solve this. So there's not enough information to actually determine it, or whether it's a parallelogram or not. Okay, so no, we cannot determine. Can you show that this quadrilateral is a parallelogram? This is similar. Let's jump up a level. Can you show that this quadrilateral is a parallelogram? Okay. So this is another sort of converse thing. So we had already seen before that if you have a parallelogram, then the diagonals bisect each other. It turns out that the converse is true. That if you happen to come upon an image like this, and you can see that the diagonals bisect each other, this is 18, this one's 18, this one's 28, this one's 28, then that actually implies that the figure actually is a parallelogram. Totally spelled that wrong. Parallelogram. Okay. So this is a yes, because the diagonals bisect each other. So that's a little bit fascinating, the fact that you can do this logical jump. You can go from diagonals bisect each other straight to bam, it's a parallelogram. Okay. This is a yes. By the way, you can prove that, and you'll probably be asked to prove that kind of stuff. All right, can you show that this quadrilateral is a parallelogram? Ooh, this one's a little tricky, because it's got two pairs of equal numbers, but they're in the wrong places. It should be that this is the same as this, and it's being cut in half by this. But that's not what's going on here. We've got a 13 and a 12. So this is a no. The diagonals are not bisecting each other, so this is not a parallelogram. Submit. Okay, we did one like this already. Let's jump up a level. Can we show this is a quadrilateral? Can we show this quadrilateral is a parallelogram? No, we cannot, because we don't know how the remaining of the 360 is spread out amongst those two missing angles. That's two unknowns. So this is a no. Okay. This is also a no. We have one pair of sides parallel and the same two sides congruent. We don't know anything about the opposite two sides. So this is a no. Can you show this quadrilateral as a parallelogram? This is a no. This is another tricky one because it looks like you got two pairs of things congruent, and we do, it's just not in the right place. This might be an isosceles trapezoid, but it's the marks made on opposite sides cut by that diagonals have to be congruent. Here they're kind of like on the same side, so this is a no, and I think this is no. Actually, I don't know about this one. Let's look at this one more carefully. So we know this is parallel. And congruent. This is a transversal. All we would need left is to show that this side here is parallel to this side. I actually think the answer is yes, but I don't know how to prove this. Oh. Hold up. Okay. Yeah, we're gonna have to do the transversal. Yeah, we'd have to look at the transversal. Okay, so let's just focus on the right side. So I'm gonna redraw this right side really quick. So we got this kind of green color. And the right side going straight down. Okay, right. I'm just sort of drawing it like if it's a transversal. These two angles here. Oh, wait a second. Oh, yeah, okay. These two angles here are consecutive interior angles, and their property is that they sum to 180. So this angle plus this angle is 180. Now, same thing happens on the other side. On the left-hand side, these are also consecutive interior, but kind of like backwards. So they have to add up to 180. Actually, I think I'm jumping ahead here. Let me not put 2. Oh, this is more complicated than I thought. Okay, so this is we're gonna pretend it's not the same as this one for a second because I haven't explained enough to actually make that conclusion. So let's just do that right now. Oh. Actually, I don't know. Same length. Yeah, I mean, I'm pretty sure the answer is yes, but I don't know how to do a proof of it at the moment. Yeah. Well, yeah, somehow this has to be, somehow these have to be congruent to each other, and then these two are also going to be congruent to each other. Let's click yes and see if we get it right. You know what? Let's click no and get an explanation, because I'm pretty sure it is yes. So let's get the explanation. Okay, so the answer was yes. Let's see what it says. Quadrilateral is a parallelogram if and only if one pair of opposite sides is parallel and congruent. Okay, I didn't know that. So, if you know one pair of sides are parallel and that they're congruent, then that's enough to say that the quadrilateral is also a parallelogram. Oh, I think I know another way. Yeah, we could prove it like this probably. Let's put this in the middle. Alright, so if you drew a diagonal, we have two triangles, and this side is the same as this side. This side is the same for both. And then this is an alternate interior angle with this other one. So the two triangles are congruent to each other by side angle side. This side, this angle, and this side are congruent to this side, this angle, and this side. So the two triangles are congruent. That implies, in particular, that this side right here with 3 marks is the same as this side right here with 3 marks. And we already know that this one's 39 and this one's 39. So we have both opposite pairs of sides being congruent to each other. So it is a parallelogram. That's one way to prove it. I mean, there may be other ways, but okay. Delete screenshot. Okay, this definitely is because opposite angles are congruent. Okay, let's go to N8. Properties of rhombuses. Okay. I think I'm going to take a break. Yeah, I'll come back to this.